Hello, good day all. I warmly welcome you to Wanies Academy. All right, so we are taking a new topic today in chemistry. The topic we'll be considering today is nanoparticles. Nanoparticles, that's the topic we'll be considering today. The set aim for this class is to explain what nanoparticles are. Then I have some objectives that I've specifically outlined for this class. At the end of the class, the student should be able to 1. Define nanoparticles. 2. State the characteristics of nanoparticles. Then 3. State the types of nanoparticles. Then number 4. State the usefulness of nanoparticles. So I commence my class in earnest. So when we say nanoparticles, what are we actually referring to? So what are nanoparticles? Now, these are tiny particles, right? Typically ranging from 1 to 100 nanometers in size. I'll say that again for clarity. I said nanoparticles are tiny particles, minute particles that typically would range from 1 to 100 nanometers in size. And these particles are known to have unique properties, right? Exhibiting small size and high surface area to volume ratio. So their sizes are extremely very small, right? Very small in size. And they are known to have a large surface area to volume ratio. So if we are to put this in proper context, explanation, now what do we refer to as a nanometer, right? Now, a nanometer is 1 billionth. That means 1 out of a billion, right? So that is mostly saying like 1, right, over 1 billion. So when we have 1 over 1 billion, right, something like this, 1 out of a billion. So a billion is known to have 9 zeros. So you have another 0 here. Then there's another 0 here. There's another 0 here. So a nano is 1 billionth, right? 1 billionth. So 1 out of a billion. That is what nano is in measurement. So this is extremely very small in size. So if you put this in standard form, it's the same thing as saying 1 times, right? If you put this in proper standard form, I'm saying as 1 times 10 raised to the power of minus 9, right? So that is what a nanometer is, right? 1 nanometer is 1 billionth. That means 1 out of a billion, right? So that is why that's how you can explain this mathematically. 1 billionth of a value. So that is extremely very small, right, in terms of measurement and size. So and these particles are known to have unique properties, and they have a very large surface area in comparison to their volume, right? A large surface area in comparison to their volume. Now, usually, because of this extreme small size, they cannot be detected by the human eyes, right? So you can't see them with your naked eyes. So, and they are known to exhibit different physical and chemical properties, right? When you compare them to their larger counterparts, right? I'm talking about the equivalent of nanoparticles, right, in larger molecules. So the properties that nanoparticles possess, right, in terms of physical properties and chemical properties are very unique to them, very specific to them. So when you compare their properties to their larger counterparts, that means larger counterparts of nanoparticles would have properties very different from that properties exhibited by nanoparticles themselves. The nanoparticles are known to sometimes occur naturally, or they can be created artificially by combustion reaction. They can come as byproducts of combustion reactions. So beyond the fact that they can occur naturally, they can be found in nature, then they can also be seen as byproducts of combustion reactions, or they can also tailor-make them specifically, right? Maybe there's a purpose you want to carry out, maybe drug delivery, right? Or maybe surgical operations. So you can use engineering techniques to tailor-make nanoparticles, right, for a specific purpose. So it depends on what you want to use them for. All right, so I haven't explained this. Now let's go to different types of nanoparticles, right? So we have a number of different types of nanoparticles. For example, we have metal nanoparticles. So we have metallic nanoparticles. Now, these ones are known to have unique optical and antibacterial properties, right? For example, we can have gold, silver, and copper converted to nanoparticles. So they have very unique optical properties. That means properties associated with light, right, and colors unique to them. So this can be metallic nanoparticles coming like gold, from silver, and of course from copper. Then we have what we call polymeric nanoparticles. Now these are made from polymers and they are often or mostly used in drug delivery systems. That is polymeric nanoparticles. Then we have what we call ceramic nanoparticles. Now these are inorganic materials with high strength and thermal stability. So that means they can withstand excessively high temperature, right, when you make use of them. So ceramic nanoparticles, right? They are mostly inorganic materials and they have high tensile strength, right? And of course, they have high thermal stability. So meaning that they can withstand extremely high temperature. Then also we have carbon-based nanoparticles, right? Like nanotubes, graphenes, and fullerenes. Now these ones have unique electrical and mechanical properties. So I just gave you 4 typical types of nanoparticles. Now since I stated earlier that nanoparticles have some unique properties that are very specific to them. So what are the characteristics unique to nanoparticles, right? For example, nanoparticles are known to have high surface area to volume ratio. So they have a very high surface area to volume ratio, and this enhances their reactivity and their interaction with other substances in nature. Then another characteristic that is unique to nanoparticle is that they exhibit what we call quantum mechanical effects. So they exhibit what we call quantum mechanical effect, meaning that when materials get to the nanoscale, their behavior, the way they will behave, right, chemically and otherwise, right, is governed by quantum mechanics, leading to properties which are not observed in bulk materials. So they exhibit what we call quantum mechanical effects, because when objects approach this extreme small size that we call the nano stage, right, the nano size, right, 1/1000th of the size of the material, the object starts behaving or exhibiting quantum mechanic behavioral patterns, so leading them to exhibit properties that are not seen in bulk or in large material. So this property is called quantum mechanical effect. Then another property unique to them is they have what we call a unique optical properties. So typically, nanoparticles can exhibit different colors and light absorption characteristics depending on their size and on their shapes. So nanoparticles, right, have unique optical characteristics or properties, meaning that they tend to produce, right, or give off different light shades and color absorption abilities, right, mostly because of the fact that they have different sizes and shapes. So they have unique optical properties or characteristics. Then they also exhibit enhanced chemical reactivity. So their chemical reactivity is well and enhanced in nature. Why? Because they have what we call a large surface area in comparison to their volume. So since they have a large surface area to volume ratio, nanoparticles are known to be highly reactive in nature. So they can be used for chemical reactions, right? The reason for this enhanced chemical reactivity in nanoparticle is mostly because of the fact that nanoparticles, right, have a large surface area to volume ratios. Now let's look at some of the applications of nanoparticles, right? Now they have a very varied, different or diverse applications, right? Now they are used in medicine. One of their uses in medicine is they use them for drug delivery in medicine. They are used for cancer therapy in medicine. Then, of course, they are used for medical imaging, for diagnosis in medicine. Then they are also used in electronics. For example, we use them in making semiconductors, right, which of course we use in electronics. Then they are also used in sensors and displays in making electronic gadgets. Then also, they are also used for energy sources. For example, they use them in solar cells. They are used in batteries and fuel cells. So that means they are used in energy sources. Then in environmental science, right, Nanoparticles are mostly used for water pollution, right? They are used for control of water pollution, and they also used for water purification, right? So for environmental science, nanoparticle also has a very relevant application, right? It's used for purification of water and for control of pollution. Then in agriculture, right? Now, nanoparticles are used for crop protection to protect crops or plants, right, from environmental effects, right? Then they're also used for nutrient delivery to enhance the fertility of the soil. Then lastly, they are used in cosmetics, right? Cosmetics, application of cosmetics. So, for example, they are used in skin care products and they are used as sunscreen. So you see, so they have very diverse or varied applications in nature, right? So with that, we have come to the end of today's class. Please remember to click on the subscribe button so as to come across more exciting videos. See you in our subsequent classes. Thanks for watching.